Hello students, welcome to the Tantray physics classes. Today we will start a series of few lectures on kinematics and motion in one dimension. Let us start with the frame of reference. Frame of reference. Number second, rest and motion, and other things will follow. Frame of reference. Frame of reference. If we want to locate the position of a particle, we have to locate the position of a particle with respect to a frame of reference. Frame of reference is a coordinate system, x, y, and z mutually perpendicular to each other. That's simply a coordinate system with respect to which the location of an object is specified. For example, have a look. We have this as a coordinate system, x, y, and z. This is a coordinate system. This is the origin of a coordinate system with the x, y, and z 0, 0, 0. Here is the object, point P. It's a point object. Point object को कैसे define करते हैं? Point object को define करते हैं अगर ये particle जो है, object जो है, if it travels a distance larger than its dimensions, then we say it is a point object. So we have to watch its activity first. So if it moves a larger distance and that distance is compared to its dimensions is very large, then we say it's a point object. Okay, now I will locate its coordinates. What is this x coordinate, y coordinate, and z coordinate? That's x, y, and z. It may be 4, 7, 2. It may be 7, 2, 1. It is x, y, and z coordinates are located. That means that simply you have located the position of the particle. Now, if it moves, you have to track x, y, and z. Okay. So now see here is frame of reference x, y, and z coordinate system, and there is a particle whose position coordinate you have located. And now, if this object does not change its position with respect to the origin of the coordinate system, then the object is said to be in rest. So if the object does not change its position with respect to origin, then it is said to be at rest with respect to this coordinate system. Okay, if it changes its position, with respect to the origin, then it is said to be in motion. That's as simple. If the object does not change its position with respect to the origin, then it is said to be at rest. Otherwise, it is in motion. Means if it changes its position with respect to the origin, then it is said to be in motion with respect to the coordinate system or with respect to the origin. Number one. Number second, I have to define certain quantities for kinematics. I have to define certain quantities for the for kinematic motion. While obviously in kinematic motion, we do not need Newton's laws as such, and we only need certain equations, and we need to define certain quantities. That is very important. We have certain quantities, physics-based physics quantities, which we have to define for kinematic motion. Now again, point number second, let me again take the coordinate system. These are the three axes perpendicular mutually perpendicular to each other. And here it is an object, particle P. And now, in order we are discussing kinematics. In kinematics, you see, again I will repeat, we need to define certain physical quantities. And then we need some equations. And that will help us solve the problems and the objectives in kinematic motion. It's a particle P here. Let its coordinates be x1, y1, and z1. And let its radius vector with respect to origin be r1. So you have located the position of the particle. And now, suppose the particle moves in any arbitrary way and reaches here. And now its coordinates are x2, y2, and z2. And now its radius vector is r, new radius vector. Position vector भी इसको कहते हैं, radius vector भी कह सकते हो, position vector भी कह सकते हैं. Particle is here, it moves in a very arbitrary way and reaches this point. Here, P prime कर दो. So from here we will define certain quantities, but that's all. This is a section figure to define all the physical quantities related to kinematics. First point, let me define the distance covered by the particle. Distance covered A, distance covered is equal to, what is this distance covered? Distance covered is the actual path traveled by the particle. ये जो पूरा distance है, path है, actual, जिस रास्ते से particle गया from this position to this point, that is the distance, zigzag distance. Distance covered is actual path traveled by the particle. और ये जो actual path है, it is simply distance, a scalar quantity. It is a scalar quantity, and इसका जो unit है, that is meters. SI unit is meter. Okay. Now, what the displacement? How do we define displacement? Displacement is if you join this initial position to the final position, that is this, and you can distance to you write as delta S. And here, from this position to this position, let me say it is delta R. The shortest distance between initial position and final position, this is called displacement, defined as displacement. So, B point, delta R, which is a vector of course, is shortest distance between initial position and final position. It's a vector, and SI unit is again meter. So here you can differentiate between distance and displacement. Distance is path, and displacement is shortest distance. Suppose you are at a particular position, you go somewhere in a very arbitrary way and come back to the same position, your displacement becomes 0, because displacement is the shortest distance between initial and final point. If initial and final point is the same, then obviously displacement is the same. Okay, we have defined two points, two physical quantities, distance and displacement, because these are very important in kinematic motion. We need to know these things. Of course, some students may feel they are very easy, but we have to start with this. Okay, now point C. That is, now what is speed of a particle? Speed is defined actual path traveled by the particle divided by time interval. Suppose when particle was here, the time was t2, and when particle was here, time was t1. So time interval is t2 minus t1. So speed of the particle is delta S, that is distance covered, by delta t. It's a scalar, and units are meter per second. These are the units. So simple. If you want to find the speed is total distance covered by the particle. You have to divide by the time interval. That means it is the distance covered in 1 second. Okay. Now D. One more definition. What is this velocity? Average velocity. Average velocity from initial point to the final point, or initial time to the final time, is displacement covered in 1 second. That means total displacement, shortest distance, divided by the time interval. So average velocity is simply delta R by delta T. That is average velocity, and it is vector, and it is SI unit is meter per second again. But what is this direction? The direction is from initial point to final point. And the tail of that direction is at the initial point, and head is the final point. And I have shown the direction. Direction is this, from initial point to final point. That is average speed. That's all. But here I want to tell you more about what's the dr, delta R, displacement. How can you calculate delta R directly from the coordinates? Okay. Now this is one point. Next point is next point. Have a look here. Again, I will make coordinate system here, x, y, and z, and here is the part P1 particle here, position here. It is R1 vector. Particle goes like this, reaches here. It is R2 here. This is the displacement delta R. This is the distance. It is time t1 here. It is time t2 here. Then particle reaches here, it is time t2. But time taken is from t2 minus t1. Okay. Now, can you tell me what is this delta R displacement? Displacement is a vector here. This is the vector. It is R2 vector minus R. Where the difference between the two vectors is taken by connecting the tips. this tip and this tip. So what is R2 minus R1? That is delta R. So delta R is R2 vector minus R1 vector. What's the magnitude of delta R? That's magnitude of R2 minus R1. That you can find, of course, root of this square minus twice R2 R1 cos of theta, cos of angle between R2. That is found by usual vector methods. Okay. Now, in terms of coordinates, what is delta R? Use this R to put this into, it's a vector, position vector. What is this position vector in terms of coordinates? That is x to I plus y to j plus z to k. This is R2 equal to negative minus karke. What is R1? That is x1i plus xy1j plus z1k. If you write it like this, delta R is equal to x2 minus x1 I plus y2 minus y1 j plus z2 minus z1 z1 k. What's the magnitude of delta R? By usual vector methods, square of this plus square of this plus square of this, that is x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. This is very handy now. ये आप कर सकते हैं, इमीडिएटली आप कर सकते हो, डेल्टा आर निकाल सकते हो जो आपको डिस्प्लेसमेंट देता है, फाइनल पोजीशन वेक्टर माइनस इनिशियल पोजीशन वेक्टर, मैग्नीट्यूड भी निकाला और कोऑर्डिनेट्स में भी लिखा एक्स और वाई में, एक्स वाई और जी में, और वहां से भी डेल्टा आर ये आप निकाल सकते हो और फिर मैग्नीट्यूड भी निकाल सकते हो. दिस इज वेरी इंपॉर्टेंट सो फॉर एज प्रॉब्लम्स दैट वी हैव टू सॉल्व और कंसर्न. अच्छा, मैं आपको एक एग्जाम्पल देता हूं डेल्टा आर निकालने के लिए. एक थोड़ा सा एग्जाम्पल मैं देना चाहता हूं. थर्ड पॉइंट जरा देखिए, ये थर्ड पॉइंट. सपोज इनिशियल पोजीशन, ये जो पोजीशन पार्टिकल का था, ये था, सपोज इट इज 3 2 1. पहले इसका कोऑर्डिनेट ये है और इट गोज टू पोजीशन ओके 7 -2 4 फाइनल पोजीशन. What is delta R? Vector delta R. By the previous formula that x position, final x position minus initial x position, that is 7 minus 3i plus final x position minus initial x position minus 2 minus of this 2 j plus final x position minus initial x position, that is 4 minus 1 k. So it becomes very simple now how to find displacement. It's a vector and you have to apply these rules to find the displacement because it's a vector. This distance निकाला easy है, distance में कोई problem नहीं है, वो तो actual path है. अच्छा, it will be 4i minus 4j plus 3k. That's all. तो जब आप इसको देखेंगे तो मैग्नीट्यूड भी निकाला जा सकता है, रूट ऑफ दिस स्क्वायर दिस स्क्वायर दिस स्क्वायर, और डायरेक्शन भी alpha beta gamma. What this delta r makes with the x-axis you can find. What is the angle this delta r makes with the y-axis, that you can find. What is the angle it makes with the z-axis you can find. That is already discussed in vectors. Okay, now what is this was all about displacement. Average velocity I told you, average speed I told you, and this is distance I discussed and displacement I discussed. Now let me go to instantaneous velocity and instantaneous speed. Okay, I want to find particle is moving actually on this path. I want to find velocity here at this point, and I want to find speed also here. So how that is done? So okay, अगर मुझे यहाँ velocity चाहिए इस point पर, because actual path तो ये है, तो मुझे इस actual path पर यहाँ velocity चाहिए. How fast or how slow I was moving here at this point, at this time, at this point. So what you do with that? The technique is very simple. What I do, let me make a different diagram. मैं एक और diagram बनाना चाहता हूँ. Let the diagram remain there. I will make a new one here. मैं यहाँ नया diagram बनाता हूँ. It is x, it is y, it is z, 0 0 0 origin. So particle is here. Particle now goes like this and reaches here. मुझे चाहिए velocity here, इस point पर. The question is, how can I find the velocity at a particular position, at a particular time? Only for this calculus was discovered. if you want to find instantaneous velocity or instantaneous position, you are not given a big time interval, you are not giving a big time displacement at a particular time or at a particular displacement, at a particular time or at a particular position. If you want to find velocity, the usual methods of this average will not work. So what you had to do, that's for this calculus was discovered. So again, the answer is very simple. I want to find velocity here at this position. So velocity, instantaneous velocity. So simple. Have a look. Instantaneous velocity के लिए ये जो point है, या यहाँ point लीजिए, ये point. इस point का radius vector ये है. How much particle, when particle was here, how much away it was from the origin. तो उसका radius vector ये है. तो वो radius vector जो है, उसको differentiate करना पड़ेगा, बस that is all. Finished. एक position पर जो radius vector है, एक खास पोजीशन पर, एक खास टाइम पर, इंस्टेंटेनियस टाइम, उस पोजीशन पर वो जो पोजीशन, उस टाइम पर जो रेडियस वेक्टर है, उसको आपको डिफरेंशिएट करना है. यू हैव टू फाइंड डिफरेंशियल कोएफिशिएंट ऑफ दैट पोजीशन वेक्टर एंड यू विल फाइंड इंस्टेंटेनियस वेलोसिटी. एंड व्हाट इज द डायरेक्शन? डायरेक्शन इज टेंजेंशियल टू दैट पॉइंट. टेंजेंशियल, अगर यहाँ है तो ये वेलोसिटी का डायरेक्शन, अगर यहाँ है तो ये वेलोसिटी का डायरेक्शन है. अगर पाथ ये है पाथ, तो आप यहां वेलोसिटी निकालना चाहते हैं, डायरेक्शन, तो ड्रा ए टेंजेंट, दिस गिव्स द वेलोसिटी. अगर यहां है तो ड्रा ए टेंजेंट, दिस गिव्स द वेलोसिटी. अगर यहां है तो डायरेक्शन के लिए टेंजेंट डालो उस कर्व पर, जिस कर्व पर ये मूव कर रहा है, उस पोजीशन पर या उस टाइम पर, और मैग्नीट्यूड निकालने के लिए उस रेडियस वेक्टर को डिफरेंशिएट करो. अच्छा, नाउ व्हाट अबाउट द इंस्टेंटेनियस स्पीड? इंस्टेंटेनियस स्पीड जो है, दैट इज आल्सो डिफरेंशिएशन. वो भी डिफरेंशिएशन है, मगर वो इस रेडियस वेक्टर का डिफरेंशिएशन नहीं है, वो इस डिस्टेंस का डिफरेंशिएशन है, दैट इज ds by dt. डिस्टेंस का डिफरेंशिएशन और ये पोजीशन वेक्टर का डिफरेंशिएशन. एंड इट इज ए स्केलर, ये वेक्टर नहीं है. इसका मतलब जो इंस्टेंटेनियस स्पीड है और इंस्टेंटेनियस वेलोसिटी है, देयर मैग्नीट्यूड इज द सेम. उनका मैग्नीट्यूड में डिफरेंट नहीं है. चाहे r को डिफरेंशिएट करो या s को डिफरेंशिएट करो, that will give you the same magnitude. But it has a direction tangential at that point, it does not have direction. So instantaneous speed, magnitude of instantaneous speed is equal to magnitude of instantaneous velocity. It is speed, it is velocity. That was very important. Instantaneous velocity, just differentiate the position vector और रेडियस वेक्टर, एंड इंस्टेंटेनियस स्पीड के लिए डिस्टेंस जो है उसको डिफरेंशिएट कीजिए, एंड दैट यू विल गेट द इंस्टेंटेनियस वेलोसिटी. नाउ व्हाट अबाउट एवरेज एक्सेलरेशन एंड एवरेज इंस्टेंटेनियस एक्सेलरेशन? दीज आर ओनली टू थिंग्स नाउ रिमेन्स फॉर काइनेमेटिक मोशन. सो फोर्थ पॉइंट, एवरेज एक्सेलरेशन. एवरेज एक्सेलरेशन कैसे डिफाइन करेंगे, क्या लिखेंगे एवरेज? अगर ये पार्टिकल है, it goes from here to here. Here it is instantaneous velocity is v1. Here it is instantaneous velocity is, okay, v2, let me suppose, tangential to the path. Okay, this is the displacement here, delta r. What is the acceleration? Here the particle was having v1 velocity at time t1. Here it was having v2 velocity at time t2. I want to know what is the acceleration of the particle in this time interval. इस time interval में particle का acceleration क्या है? As simple as that. This is the velocity at time t1 and particle moves, and this is the velocity at time t2. This is the displacement. What is the average acceleration? Average acceleration is defined as final velocity vector minus initial velocity vector by t2 minus t1 is equal to delta v by delta t. What is the direction of the acceleration? Is the direction of acceleration the direction of final velocity? No. Is it have the direction of initial velocity? Not again. It has the direction of v2 minus v1. तो v2 minus v1 का डायरेक्शन अलग निकालना पड़ेगा by usual method and rules. इसका जो डायरेक्शन है v2 minus v1 का जो टोटल नेट डायरेक्शन आएगा, वही आएगा एक्सेलरेशन का डायरेक्शन. So it is vector obviously, and it is SI system is meter per second square, SI unit. Now what about instantaneous acceleration? Instantaneous acceleration. Instantaneous acceleration is just, मुझे यहाँ acceleration चाहिए, इस point पर acceleration चाहिए. अब आप इसको यहाँ tangent डालोगे, वो नहीं डालना है. वो tangent डालने की बात जब आएगी, वो instantaneous velocity का direction देता है. यहां टेंजेंट डालने से आपको इंस्टेंटेनियस एक्सेलरेशन का डायरेक्शन नहीं मिलेगा, लेकिन यहां पर जो वेलोसिटी है, ये वेलोसिटी इंस्टेंटेनियस वेलोसिटी जो है, यहां पर जो इंस्टेंटेनियस वेलोसिटी है उससे आपको एक्सेलरेशन मिलेगा। कैसे? ये जो वेलोसिटी है इस पॉइंट पर या इस पोजीशन पर, उसको डिफरेंशिएट कीजिए, दैट इज इंस्टेंटेनियस एक्सेलरेशन। तो इंस्टेंटेनियस एक्सेलरेशन का वही डायरेक्शन है जो इस डेरिवेटिव का जो डायरेक्शन है, आपको इस डेरिवेटिव का डायरेक्शन निकालना पड़ेगा, तब जाकर एक्सेलरेशन का डायरेक्शन वही होगा। तो डोंट बी मतलब अंडर दिस इंप्रेशन कि भाई यहां पर टेंजेंट डाल करके हमें एक्सेलरेशन का डायरेक्शन मिलेगा, नहीं, dv by dt का डायरेक्शन निकालना है, जो कोएफिशिएंट ऑफ डेरिवेटिव का डायरेक्शन होगा वही एक्सेलरेशन का डायरेक्शन होगा। वो कोई मतलब दिखने में कोई डायरेक्शन आपको मिलेगा नहीं, वो निकालना पड़ता है इन रियल टाइम सिचुएशंस। ओके, नाउ अगर फोर्स की बात है, अब मैं देखें ये जो एक्सेलरेशन है, एक्सेलरेशन इज ऑलवेज कॉज्ड बाय द फोर्स, दैट इज वेरी इंपॉर्टेंट। एक्सेलरेशन ऑफ कोर्स वी हैव डिफाइंड एक्सेलरेशन, लेकिन हमने ये नहीं कहा कि एक्सेलरेशन, हु क्रिएट्स दिस एक्सेलरेशन, ये तो न्यूटन लॉज का काम है। होता क्या है एक्सेलरेशन? डेरिवेटिव ऑफ वेलोसिटी इज द एक्सेलरेशन, बट हु क्रिएट्स द चेंज इन वेलोसिटी, हु क्रिएट्स द वेलोसिटी डेरिवेटिव, वो काम है फोर्स का, दैट इज द पार्ट ऑफ न्यूटन्स लॉज। मगर फिलहाल हम ये कह सकते हैं कि अगर फोर्स है दैट कॉजेज एक्सेलरेशन, एंड फॉर्मूला इज दिस। So when you apply net force on an object of mass m, it creates acceleration A, and the rule is this: net force applied on the object is equal to mass of that object multiplied to acceleration of that object. This is the rule. ये force निकालना पड़ता है. This force is the agents जो फोर्स अप्लाई करते हैं, लेकिन राइट साइड में इट्स ए नाइस गुड क्वांटिटी, ये मास इनटू एक्सेलरेशन है। ये फोर्स देखना पड़ता है इज इक्वल टू मास इनटू एक्सेलरेशन, मास ऑफ द ऑब्जेक्ट एंड इट इज एक्सेलरेशन, एंड फोर्स यू हैव टू कैलकुलेट व्हिच आर बीइंग अप्लाइड बाय डिफरेंट एजेंट्स। उनका वेक्टर सम निकालना पड़ेगा, उनका रिजल्टेंट निकालना पड़ेगा। सो दैट इज ऑल। दिस इज टोटल काइनेमैटिक्स you need for doing kinematics. But now, what are the equations which are useful to do kinematics of bodies? So I want to give those equations to you, which are very, very useful and important. Fifth point. It's a particle here and it moves. Okay, let me again take the coordinate system so that things become easier to visualize. It's a particle here. Okay, it's the radius vector of the particle, and its coordinates are x1, y1, z1. It's a particle here. Now, let me tell you before I do this, give you the equation, let me tell you one small important thing. What is one-dimensional motion? What is two-dimensional motion? What is three-dimensional motion? Let us define it once forever. Fifth point. One-dimensional motion is when the only x coordinate of the particle, or only y coordinate, or only z coordinate, any of the three coordinates, any one of the three coordinates is changing. That's all. If only one coordinate, okay, x, let me suppose, if only one coordinate x, that means particles moving in the x-axis, if only one coordinate x is changing, then it is one-dimensional motion. As simple as that. अगर ये मतलब पार्टिकल के तीन कोऑर्डिनेट्स है, अगर इन तीन कोऑर्डिनेट्स में से पार्टिकल जब मूव करता है सिर्फ एक ही कोऑर्डिनेट चेंज होगा तो समझो वन डायमेंशनल मोशन है। ओके, इफ टू कोऑर्डिनेट्स चेंज ड्यूरिंग मोशन, देन इट इज टू डायमेंशनल मोशन। See, obviously, if all the three coordinates change, then it is three-dimensional motion. So when the particle while in motion, it is all the three coordinates change. That means the particle has a three-dimensional motion. If all the three coordinates change during the motion, that means it is three-dimensional motion. ये मैं आपको बताना चाहता है before we go to the kinematic equation. So simple. Because some certain motions are only one dimensional, there becomes the situation becomes very easy. आपने एक object है release किया, it's a one dimensional motion. It moves in a straight line, goes down. Suppose a boy moves in a straight line in any direction, and that direction you can take as the x-axis. It is one-dimensional motion. So for one-dimensional motion, only one coordinate changes, that is one-dimensional motion. Sixth point, let me go to those kinematic equations which are needed to describe the motion of the object. Kinematic equations. Again, simple. Six. Kinematic equations. So here we have, so you see, we have a set of equations, and those set of equations will solve all the problems and objectives of kinematics in principle. उसूली तौर पर हमें we will be able to solve. लेकिन maybe when we actually go to the problem, हो सकता है हमें इंटीग्रेशन ना आता हो, डिफरेंशिएशन ना आता हो, वेक्टर को एनालाइज ना करना आता हो, तो उस सूरत में हम नहीं कर सकते. लेकिन मैं ये कहना चाहता हूं, राइट नाउ वी हैव एवरीथिंग विद अस, जिसको यूज करके हम कोई भी प्रॉब्लम काइनेमेटिक्स का कर सकते हैं in an easy way. Sixth point, first of all, when the particle moves, you see, particle moves, it starts from some position, goes to another position. During the motion, it has velocities, it has accelerations, there may be forces acting on the object, so many things are there. Particle has initial position, then particle has final position, particle has initial velocity, then finally after some time particle has a different velocity. So what we may be asked to find in all those scenarios, we may be asked to find what is the displacement covered by the particle, what is the distance covered by the particle, what is the velocity of the particle at a particular time, what is the velocity of the particle when it covers 10 meters of distance, the final velocity is this, what was the initial velocity when the acceleration is given. So all these things can be asked. We have the rules, we know the definitions of all those quantities which we may be asked to find. Now we need equations. We need definitions, we know. Now we need the equations to find them. Okay. It's a particle here. Now let me leave the coordinate system. It's a particle here, and my better is to make a coordinate system so that it is very clear. X and Y and Z. Particle moves, okay, moves like this and reaches here. It is delta R, it is delta S, it is R1, it is R2. Right? First particle going from here to here. Now, it is time t1 here, it's time t2 here. The question is, what is the velocity of the object at time t2? That's the question, can be asked. But he has to give initial conditions. If he asks me what is the final velocity, he has to give me the initial velocity. He has to give me the time. He has to give me the behavior of the particle moving. The behavior of the particle moving means he has to give me the acceleration. He has to give me the acceleration. Okay. Now, kinematics में जो मैं condition apply करूँगा, although that is not the general condition, यहाँ मैं एक special condition apply करूँगा, constant acceleration, constant acceleration, constant acceleration. Under this constant acceleration, what are the possibilities? There are set of equations which are used for this constant acceleration. So in most of the situations that you encounter, हर जगह acceleration constant होता है. In some cases, if acceleration is not constant, then we will show a little difference. Rules क्या different है, कुछ भी different नहीं है, calculus use करना पड़ेगा. Rules तो यही है, वहाँ calculus का use करना पड़ेगा जहाँ acceleration change हो रहा है. लेकिन फिलहाल acceleration हम constant लेंगे ताकि हम वो set of equations develop करेंगे जो simpler है. और fortunately जो भी problem आपको आता है वो constant acceleration के अंडर ही आता है. अच्छा, तो मुझे चाहिए velocity t2, ये चाहिए मुझे. दिया होना चाहिए velocity t1, that is u, plus acceleration into this time interval t2 minus t2 into t. मगर ये t क्या है? ये instantaneous time नहीं है, ये time है t2 minus t1. इसको डेल्टा टी भी लिखते थे, वो भी ठीक था. But finally you have familiarity with this. This is the answer. और ये आंसर तब भी है, ये आंसर तब है when the motion is 3 dimensional or maybe 2 dimensional or maybe 1 dimensional. This is general equation. लेकिन अगर motion 1 dimension है, तब आप ये लिख सकते हो, velocity, final velocity at time t2, x component is equal to ux plus ax into t. ये आप लिख सकते हैं. What is the y component of velocity? Final velocity at time t2. What is the y component of velocity? That is uy plus ayt. What is vz? That is uz plus azt. Well, that means every vector equation is basically 3 equations. अगर आपका 1 dimensional motion है तो यूज करो ये इक्वेशन. अगर मोशन x डायमेंशन में है तो ये करो यूज. अगर मोशन वन डायमेंशनल है लेकिन वाई डायरेक्शन में तो ये करो, अगर जी में करो तो ये करो, लेकिन जनरली आपका मोशन एक्स प्लेन में होता है, अगर जी में भी होगा तो वो भी कोई बुरी बात नहीं। अच्छा, सो यहां पर एक चीज आपने सीखा, एवरी वेक्टर इक्वेशन बेसिकली थ्री इक्वेशंस, थ्री स्केलर इक्वेशंस। दिस you need not put vectors here and here because components are not vectors basically। ये वेक्टर इक्वेशन ये है तो ये तो कंपोनेंट इक्वेशंस है। Component of a vector is not a vector unless you multiply it by I, J or K. Okay, now this is one equation. So with this I want to end up this lecture. Tomorrow I will continue the lecture. Second lecture I will give on this kinematics. Within 3-4 lectures it will be complete. But you do this lecture, you watch it many a times and practice with it so that these things you remember, and when we apply these things to the problems and objectives, to the cases, you feel easier with that। तो फाइनली मैं आपको कहना चाहता हूँ कि आप तांत्रे सर फिजिक्स क्लासेस को सब्सक्राइब कीजिए, ऐप को डाउनलोड कीजिए गूगल स्टोर से, ताकि आपको फर्दर सारे लेक्चर मिल जाए। आपको फिजिक्स में कोई कहीं जाने की जरूरत नहीं है, घर में बैठकर मेरी लेक्चर सीरीज अटेंड करो। मैं प्रॉब्लम्स भी दिखाऊंगा, ऑब्जेक्टिव्स भी दिखाऊंगा, व्हाट एवर यू नीड फॉर टू क्वालिफाई नीट, JEE, IIT, I will provide you everything, anything on this platform. You don't need to bother. Now you see IIT students, those who prepare for IIT entrance, they may feel it easier or they may feel it not that up to the mark, but they have to wait till we address their problems। तो उनके जो प्रॉब्लम्स है वो भी आहिस्ते आहिस्ते हम एड्रेस करेंगे, उनको भी हम दिखाएंगे जो उनको नीड है, लेकिन यहाँ से तो बेस से ही स्टार्ट करना पड़ता है। With these words, I thank you because you are regularly and you are constantly watching my lectures. Thank you.